Imagine you are walking on a beach. Someone sweeps a metal detector over the sand, freezes, digs, and pulls out a coin that has been buried for decades. It looks like magic, but it is not magic. It is physics, engineering, and one very clever trick. A metal detector does not sense metal. It senses how metal distorts electromagnetic fields. Inside the detector's coil is a loop of wire carrying an alternating current. That current creates a magnetic field that pushes down into the ground. Dirt, sand, and rocks mostly ignore it. Metal doesn't. When that field hits a buried coin, the electrons inside the metal start to move. They swirl into tiny loops called eddy currents, and those currents create a magnetic echo that pushes back against the detector. The machine listens for that echo. Different metals conduct electricity differently, so they distort the magnetic field differently. Copper leaves one kind of signature, aluminum another. Iron behaves differently from gold. This is why detectorists learn to ignore some beeps and dig others. The detector is basically reading the metal's accent, and the soil matters. Wet sand, salt water, mineral-rich dirt, all of them throw noise into the signal. Sometimes the ground is louder than the treasure. That's why gold can be surprisingly hard to detect. It responds strongly, but it often sits in soil packed with minerals that drown out the signal. That's when prospectors switch to pulse induction detectors, which fire short bursts of energy and measure how long the echo lasts. Mineral noise dies instantly. Gold lingers. Depth is another misconception. People imagine detectors finding objects meters underground. Not even close. A coin becomes invisible deeper than 20 to 30 centimeters. A larger object may be detected deeper, but not dramatically deeper. Magnetic fields weaken extremely fast with distance, and the return signal weakens even faster. Yet detectorists still find tons of stuff because the world constantly brings metal back toward the surface. Rain erodes soil. Waves churn beaches. Plows flip the ground over. You're not detecting deep treasure, you're detecting relocated treasure. Another surprise, metal detectors respond more to conductivity than size. A tiny piece of pure silver can scream loudly. A big chunk of stainless steel might barely register. This is why aluminum trash mimics the signal of gold. The detector isn't impressed by size, only by how easily electrons move inside the object. And no, detectors aren't magnets. They don't pull on anything. They simply send out a field, wait for metal to react, and listen for the reaction. It's like sonar, but with electromagnetic fields. This same principle is used in airport scanners, industrial inspections, archaeological surveys, even bomb detection systems. Once you understand the trick, it becomes obvious why metal can't hide from a changing magnetic field. The moment the field hits metal, the electrons react, and the detector hears it. So when someone digs up a coin, they found it because thousands of electrons inside that coin got excited and sent back a tiny magnetic fingerprint. If you like science behind everyday things, subscribe. You clearly pick interesting videos already.